Yes. Okay, so hello everyone. As said, I'm Aurélien. I work for Yocto, a design house for mostly embedded systems. And I will talk today about enhancing reproducibility in Yocto builds. So let's start by why we would want to target reproducibility. So yeah, one of the things you might want is be able to build your images in the future, in 1 year, 2 years, 15 years. So of course that starts with archiving your sources, your downloaded sources, and using BB BB no network. But there's more to that. You may want to be able to binary identify a release, not only a binary release, but any binary build of source release if you have a distributed build. It happens. Of course, non-reproducibility can introduce fringe behaviors in some cases inside the system you build. And that's something you want to avoid. If you're working on a sensitive system that some might want to attack, that's almost any system nowadays. Attacks can happen at the build stage, and you can circumvent them at some point, at some level, by matching the output of several independent builds. Some do that. You might want it, that's a particular point of interest to me, to perform differential updates over the network, which need to be efficient. Bandwidth is costly. And so if you already have significant differences between successive builds, the output of successive builds of the same revision, imagine what it becomes when you build successive revisions. Yeah, there are also some audits and certification processes that require you to attain some level of reproducibility in your builds. So let's talk about the impact of reproducibility on your process. So if you want reproducibility, of course, well, you have to work for it. You have to fix reproducibility in your build, but you also need to test it continuously because it can be broken by any change you make, by any package you update in your images. And that's what the courier do, actually, but we'll talk later about it. Of course, with that in mind, deployment may be a bit more complex, maybe longer, because if you perform several builds to check that the output match, it takes as much more time. And because if you do find mismatches, differences between your build outputs, you'll have to work to fix that. So yeah, of course, it is costly, but also once you have reproducibility well in hand, long-term maintenance is made more reliable because you fully master the output of your builds. For now, let's talk about reproducibility in Yocto builds, the state of the art and the history of that. One huge important step that was made for reproducibility happened back in Pyro when per-recipe sysroots were introduced. It is a given for now, but back then, before per-recipe sysroot, when you had the global sysroot, shared sysroot, depending on the order in which your packages were built, you could have bid fail or not. So this was a major non-reproducibility. For now, we were mostly talking about reproducibility of the output, but there was a matter of if the fact that the output is produced even reproducible. Then at Rocco time, there was a particular focus brought to introducing reproducibility in the build of the core layer. There was a variable created, defined, build reproducible binaries, which introduced an option, a check-in. Yes, I want my build to be reproducible. And with in that to that aim, all the other variables were introduced, reproducible timestamp rootfs, and yes, source date epoch, which isn't a Yocto specific, which is a standard variable used from the environment by many open source projects to remove the non-reproducibility introduced by build dates inside, for instance, ELF files. And reproducible timestamp is used with the globally the same aim. And all of that was encompassed inside the build class called reproducible build, which at the time was to be inherited. Since hardnot, all packages provided by the core layer are guaranteed 100% reproducible. And this is enforced by a continuous test by the auto builder. Then since Kirkstone, the class reproducible build has been merged first into base.bb class, then into image.bb class directly to make reproducibility a first-class citizen. That is, it is not an option anymore. Yocto's core layer makes it so that all its builds, all the packages it builds are reproducible. Then let's talk about the limits of reproducibility in Yocto. First obvious limit is that there are quite a few layers above the core layer, and most, if not all, of those layers aren't known to be reproducible. In particular, meta open embedded, few layers, are undergoing work, significant work to get reproducibility. And there are tests in place that are performed weekly, but for now it isn't fully reproducible. Non-reproducibility can happen mostly because of three sources of non-reproducibility. Absolute path captured during compilation for inclusion inside version strings or as part of debug output. The build system can also look at the build hosts architecture or operative system to select a set of build options, compilation options. And also, you still have packages, programs, libraries that directly capture the time either from the source code or from the build system. And that's all things we have to look for and to fix. Also, reproducibility is guaranteed by the core layer for packages, but you may want bit identical images. The file system, the final image at the level you take it, particularly in the case where you want delta update, because if you have differences between your updates between two successive builds of the same sources, imagine what it becomes when your source first change and you do an actual update. So at that level, the core layer doesn't guarantee reproducibility yet. Difference appear during file system generation, depending on the file system. And if you use DMVT, which isn't provided by the core layer, there's a mistake on my part here, but if you use DMVT, which is a common need, since security is the need for everyone nowadays, the current process in place for that isn't reproducible. And there are also things like post-install scripts. For instance, the font config stores its cache inside folders named after UUIDs, randomly generated UUIDs, and of course, that isn't reproducible, but that doesn't appear inside the font config package. That appears after the package has been installed. So let's look at what we can do to improve reproducibility, or ideally get to complete reproducibility of an image. Disclaimer for this part. I'm taking the point of view of a user of Yocto. I'm not, as of yet, an active contributor to core layer or any standard layer. And I will talk about how we can circumvent flaws in reproducibility of lower layers from our own top layers. Also, other disclaimer, my work on it has been made on as part of a project based on Yocto hardnode. And as mentioned, things have changed, particularly around the core layer and MetaOpen embedded since then. So depending on the version of Yocto your work is based on, sorry. Some of the fixes I am presenting to you may not be needed anymore. So the first big part is to make ext4 reproducible. Actually, there are recent changes inside E2FS progs aimed at reproducibility. And E2FS progs can be used in a purely, completely reproducible manner from version 1.47.1, which is the version used from Stayhead, but not exactly in the versions in versions earlier than that. So of course, you can update it with Xbox in your own layer, and the main impact of that is that E2FS will take source date epoch into account. Before that, there's a variable E2FS fake time that is also taken from the environment, the build environment of E2FS, but it isn't taken into account everywhere in the metadata of the ext4 file system. Source date epoch is more exhaustive. Depending on the version of Yocto and E2FS you're using, you're starting from, the update of E2FS, of course, may force you to upgrade or patch other packages. BTFS tools, if used by one of your recipes, is one of them because of the API change, breaking API changes inside the E2FS prior to 1.47.1. Once you have that gold revision, you need to set up MK2FS parameters in your image. So there's a timestamp, build timestamp to set, both through E2FS progs fake time and through source epoch. Sorry, but and I don't have the name, but yeah, the one I mentioned just before. Sorry, source date epoch, yes. But usually it is already set by a global configuration of Yocto in the global configuration. You have a UUID to define and a hash seed. Here I give an example where everything is set with fixed values, completely arbitrary values. But depending on why you need reproducibility for, you can derive them in a reproducible manner from the contents of your sources or from the SHA of your latest Git commit, whatever. This is just an example. The important part is what is passed, what is added to the extra image assembly for X4 here. But there's a catch. Because if you're using the image type ext4, the last step of the image command that does that is to call fscheck, fsck, and for some reason fsck introduces changes and not reproducible changes inside the images, the image it checks. So you have to patch the class, so to speak. There was an interesting speak 2 hours ago, maybe, about how you can do that. There are several ways. The easier and easiest and ugliest way to do that is to copy the class inside your own upper layer and to modify it there. Or you can contribute back to the core layer. But at some point, this line has to go. Okay. So once you have a fixed X4 generation, for instance, if you're using DM Verity to authenticate your image, your file system, there's also parameters to pass to Verity setup. Unfortunately, Verity setup, as it is called by meta security, the class handling DM Verity inside meta security, doesn't take extra image CMD or any other way of passing extra arguments. So until Kirkstone, we can hack that by passing extra arguments to DM Verity image data block size, which is obviously used to pass block size to the dedicated flag, but which isn't quoted when it's used. So we can add other flags and whatever we want. Unfortunately, or fortunately, in later revisions of meta security, it still isn't quoted, but it is used in other ways at other places where we can't do whatever we want with it, and there is no substitute. So again, we have to patch, quote patch unquote, the class doing that, so that it takes extra image CMD or some other variable to introduce extra arguments. And the arguments we want to introduce are salt for the hashes, the hash tree, and UUID, fixed or at least reproducible, for the device created. Okay. Sorry. Then there's a matter of kernel and kernel modules. The kernel itself actually is globally reproducible for now, but changes. There are things in the kernel that make modules not reproducible. In particular, if you're using patches to the kernel, and I saw 2 talks ago a discussion on the fact that maybe it's not a good idea to apply many patches to the kernel. Even with one patch, you introduce non-reproducibility here because for the kernel, the patcher used is Git, but anyway, it introduces it creates a new SHA each time a patch is applied, starting from the same revision, because I suppose the date of application is used somewhere, but sorry, blah, blah. See, if instead of applying patches to the kernel, you use your own repository with a branch ready to be picked and fetched, you don't have that problem. And the real problem at the end is that this SHA-1, this non-reproducible SHA, will end up in the kernel version, and the kernel version, of course, is present in the path for kernel modules. Of course, if you don't use external kernel modules, you don't have the problem. Also, for kernel modules, there's a possible variable module version that is not much used, but where it is used, modpost adds to the module a field association that it generates from an ND4 sum of other sources. And for some reason I didn't understand, this ND4 sum isn't reproducible either. And it is fully optional. Actually, modded version usually isn't needed. It usually isn't used. So simply, if you don't use module version, it removes that non-reproducibility from your modules build. And there's the variable kbuild build timestamp, which once again introduces a fixed build timestamp, but specifically for the kernel and its modules. It's already used by the default kernel classes for the kernel, but for external modules you add, it may need to be specified explicitly. Okay, then there's a matter of health metadata. There are mainly two factors of non-reproducibility inside health files, either programs or libraries. And I'm not fully aware of why those non-reproducibilities appear in some binaries, in some packages, and not in others. But the fact is, we can remove them globally, and it doesn't have another cost than removing something that is purposefully non-reproducible. The first non-reproducibility is the build ID introduced by the leaker as an option inside ELF files, so that each build can be identified. Of course, this is contrary to reproducibility, and it is asked explicitly of the linker during its build inside the class, or includes the recipe, or includes our classes used by the GCC recipe, because the -- enable linker build ID is passed during the build of GCC. So you have to remove it from extra O accounts. And when this is done, this is one less reproducibility. And then there's a matter of mini debug info in strip binaries. During do package, the global debug info, debug symbols, etc., are extracted from the full ELF and moved to the file tree, which will produce the debug package. But by default, there's still a debug symbol called no, I don't have the name, sorry, but which is symbolically called mini debug info, which points to the debug file, the full debug file, and it is it can be simply this behavior can simply be changed, inhibited by setting inhibit package debug split to 1 inside your Yocto global configuration. And I also mentioned earlier the fact that cache repositories for config are named with not reproducible UIDs, random UIDs initially. So this can easily be fixed because fccache calls UUID generate random, but you can also use UID generate SHA1, which is reproducible based on UUID named used as namespace. Sorry. And so here I quickly go over this, but this is an implementation of how you pass such a namespace optionally to the configure, then to the makefile, and from the recipe. And so you can set your font config UID namespace inside your recipe or BB append and have it go all down to the source, so that UIDs generated for config cache directories are fully reproducible. Then there's the matter of the NSS libraries, which are less universally used, but those are cryptographic libraries. And if you use them in conditions in which you have to comply with FIPS 140, which can be the case if you are based in the US or if you sell to the US. Those libraries are accompanied, some of those libraries, those short files are accompanied by signed checksums. And unfortunately, those signed checksums are made in a way that isn't reproducible. So if you have to comply with FIPS 140, that's something you can do without. But if you don't, you can simply remove the signatures as shown here. So simply remove the checksum, then prevent the post-inst from signing it. Okay. For this last tip, I would like to present to you the global way, high-level way I use to find what introduces non-reproducibility, and not to fix it, but to locate it. So you can have differences appear inside the generated OTFS or after that during the image creation. If it's during the image creation, you will quickly find the culprit inside the do image scripts tasks defined by Yocto. But it's in the OTFS, there are still two cases. The files incriminated can be part of a package installed, or they can be installed by a post-inst. If it's the latter case, they should still be evidently associated with the package and recipe. And so in the post-inst from the recipe, you should quickly find how the file is created. Then if the file instead is installed explicitly by a package, if it's a text file, you can use the file name and the matching parts between various builds of it to find what generated it. If you need to remove it, if you can circumvent the non-reproducibility. If it's a binary program, a library, an ELF file, it will be mostly stripped in the OTFS, but you can use the unstripped version from the image subdirectory of the world here to find the section and ideally the symbol corresponding to the changes. Changes that you will have located more precisely using, for instance, a diff between hex dumps of various bits of the file. And once you have located the symbol, once you have located the section, you can follow from there in the sources and find why it is that there's a variation here. Okay. So I'm nearing the end. So I quickly talk about performance in Delta updates. So the first point is that when you work for Delta update performance, you need your timestamps, source, UIDs, or whatever to be strictly fixed, constant, and they either derived from the software revision or whatever changes between revisions. They will introduce more changes between successive revision builds than needed, which won't help your Delta updates. But in the end, working fix by fix, you can and if you get to it, you will get to 0 bit of difference between successive builds of a given revision on different hosts at different times at different paths. Okay, so I'm done. And I'm sorry, I took a bit more time than I would have liked. I'm afraid there isn't time for questions.